Good morning to everyone. I am Manoj. We are going to give the final presentation of the PBL, and our topic was temperature and CO2 analysis. As the title says, climate data analysis web app, which focuses on analyzing the relationship between temperature and CO2 levels using real world climate data. This web based application not only performs data processing and visualization but also emphasizes ethical handling, innovative programming techniques, and user interactivity. Our evaluation is based on four key pillars: programming, ethics, innovation, and creativity. Through this project, we aim to highlight how data science and web technologies can be used to gain meaningful insights into climate change. And the next slide is evaluation matrix and analysis. To analyze the relation between temperature and CO2 levels, we leveraged powerful Python libraries such as Flask for web interface, Pandas and NumPy for data handling, and MATLAB for visualization. We start by uploading CSV datasets which were violated and cleaned. This included handling missing values and NANS through interpolation. Then we generated visual insights using line and bar charts to observe trends over time. We also created statistical summarizers and made these accessible via Flash endpoints with options to generate PDF reports. Ethical considerations. Since we are dealing with environmental data, ethical data handling is important. We ensured proper file formats and data integrity validation. Our system avoids storing any sensitive or personal information. Any data issues such as infinite or missing values were handled with interpolation to maintain reliability. The tool provides us clear feedback on errors and most importantly emphasizes transparent and responsible reporting of insights, which is vital in climate change analysis. And my next friend is going to tell the further presentation of this topic.
Good afternoon, everyone. Myself Navin. I am telling innovation in approach. First one, we have combines multiple Python libraries for a rich interactive applications. This means the application leverages various Python libraries like Pandas, Matplotlib, etc. to create an engaging and dynamic experience for users and add customer features, growth rate and anomalies per capita analysis. This means growth rate is a calculates how values change over times, like sales and population, etc. And per capita analysis means analyzing data on a per person basis, making comparison more meaningful, and enables export of dynamic plots to downloadable PDF format. Users can generate interactive plots and then export them as PDF, making it easier to share insight or include them in reports. And RESTful architecture allow flexible integration with front-end tools like a RESTful API design allow the back like Python likely using Flask or Fast API to communicate efficient with the interface like React, Angular, and even simple HTML pages, and extends Flask behind static site uses by embedding analytics. Means instead of using data visualization and analytics, making the application more powerful and interactive, and creativity in design and implementation. Here we have user-friendly interface by HTML templates and endpoints. Means the front end is built using HTML template, making the UI easy to navigate. Endpoints, probably REST API or Flask routers, allow user to interact with the backend smoothly, and visually expressive plots covering trends, correlation, and change. Means the data is presented using visual rich graph that help users each. Means that is trends over time, correlation between variables, change in matrix. Efficient layout of three-plot visualization for clarity. Multiple visualization like a three-panel layout are used side by side to provide a clear comparison. Creativity, future engineering for deeper insight. Example CO2 growth anomalies. Advanced calculation are done before plotting CO2 growth rate show environmental trends. The step helps user uncover insight that raw data alone might not reveal. Balances technical depth with essentiality for non-technical users. Means the system is technically but still easy enough for non-expert to use. This balance makes the tool more i- inclusive and widely usable. Thank you.
Good afternoon, everyone. Myself Vinayak Katare. So I am explaining about the final output of our code. As you see, we create the buttons like upload process, view statistics, and view plot, download plot PDF, and download the summary. So when we click this file, choose file, it redirect to our directory, which is our raw data is present. We take the raw data from the internet and we upload it. By uploading that, here shows the uploaded file name, and by pressing this upload and process, the file will upload to our data. And next, by the view statistics, here see, by uploading by pressing a view statistics, we got the mean and the max, which is our data. In that, the count and how much we take, and max, minimum, mean, and the standard deviation, that are that's all. So by clicking the view plots, we got the these three graphs. And by clicking this PDF, three graphs PDF, here we see that this is plot and scatter and bar graph. So by analyzing this all, we can find out how much the increasing in global warming, and how much increasing the temperature, and how much the fossil fuels and other pollutions will affect our environment. So, and next, here the another button is called download summary as a text button. So we get final summary of the book. So we take the year from 960 to 2024, and the CO2 emission range is this, and temperature range, and correlation between fossil fuels and temperature. So now we can see the final code output. See, here is our final output code. So here we take a flask and JSON, and pandas numpy for automation, matplot for plotting the graph, and IOs for storing the whatever our graphs, and base for the get the images as a PDF. So here is our attributes. The file is not present in like a file form, that it generate message. And if a file is not in a CSV form, so it generate and a file is not selected, and the file is not uploaded, or the file is incorrect. So we take the data frames, and here see we convert the whatever our CSV file to data, and then this is plotting for a graph. So we plotting the graph from the same data, three graph we have to plot. So um, for taking a same as three, we use subplots. Here we take a data and year, and CSU total, and we label that CSU emission total, and the color is blue. And then we take a year for the scattering same data plotting. So here is CO2 concentration, and we label as CO2 concentration in ppm. It is green, and this shows the global average temperature, and we label as global average temperature in degree Celsius, and we label as here. Here x-axis is first graph. Here x-axis is um, year, and y-axis is the values, and here we label the first graph as a type temperature. Here we see this plot dot to small box on the description of the our whatever that lines, colorful lines shows what like concentration of temperature, and x rotation 45 minutes. Some here chances of overlapping the values which are present in x-axis. So we rotate it as 45 degree. Same this is for scattering graph and label fossil fuels consumption and y level as global average temperature. Here tied and level for adjusting the graph, sizing the that three graphs. Here we define the function called download plot PDF. Here see we that axis plot subplot it creates three containers for download for image and first graph for plot like which is line graph and second scatter and bar graph. Here we same as we plotting the graph axis dot one for first container. So we define this all attributes and values same as for axis 1. It is for secondary container which is our scatter graph and this is for our third graph which is bar graph. So here this code defines our final text as a summary of our as we see previous summary of our code and get the images as a PDF. See the final code. Here is our final interface. By uploading, it shows global.csv. And I upload the message. The file is uploaded. By clicking wave statistics, we get that 25%, 50% count, max, mean, and minimum value and standard deviation for all our attributes and values. And by clicking the wave plot, I got the final. Here we can see uh, blue lines represent CO2 emission as a total and CO2 concentration in ppm for green and global average temperature is for green. And this is scatter, this is bar graph and we by the graph as a image and download summary shows the summary of our code. So I hope this code is understood uh, is complete and meaning. We use a simple libraries for simple for plotting the graph, analyzing the whatever trends, and by analyzing this, we can predict the global warming, whatever temperature is high, and how much is average temperature. So that's all. Thank you.
Myself, Nandish, I'm going to explain the buttons in the our webpage and what they trigger. Firstly, to upload the CSV file to our website, we use the upload and process button, which triggers the route called upload CSV, which helps in uploading and processing the data, cleaning and new features, and also check the all attributes are fulfilled. And for the insights to the user, view statistics button is there, which triggers the statistics routes, which displays the numerical summary stats of the dataset. And for the visual insights of the dataset, uh, we have a button called view plot, which triggers the route called plot, which returns the show line scattering and bar graph of the data. And for the downloading of the insights, we have two buttons called download plot as PDF, which triggers the download plot PDF route, which helps to download the visual insights of the data in PDF form, and the statistical insights of the data can be downloaded in as a text file. From the At last, from the our presentation, we can conclude that the climate data analysis project successfully demonstrates the integration of data science techniques and interactive web technologies to analyze global temperature and CO2 emission data. The achievements of our project: accurate data processing and feature engineering, and visual exploration through line scatter and bar charts, exportable insights in both PDF and text formats, and last, ethical coding practices and reliable user interface. The project fulfills its goal of providing a comprehensive, accessible, and ethical tool for climate trends analysis. Thank you.